Hi dear students, I welcome you all to my class. In today's class, we will be studying about dimensional analysis. By the end of this class, you will be able to understand what are dimensional quantities, what is dimensional formula and dimensional equation, the difference between dimensional quantities and dimensionless quantities, and you will understand the application of dimensional quantities, and you will be able to use the dimensional quantities for various applications. All the derived physical quantities can be expressed in terms of some combination of the 7 fundamental quantities, and these quantities, fundamental or base quantities, are known as dimensions of the physical world, and these dimensions are denoted by a square bracket. The 3 dimensions in mechanics are L for length. We know the unit of length is meter, but the dimensional quantity is L within bracket, and M for mass, T for time. And we have 7 fundamental quantities. What are they? Length, mass, time, electricity, temperature, then luminous intensity and amount of substance. So, for electricity, A is the dimension of electric current, thermodynamics, K is the dimension of temperature, and in optics, CD, candela is denoted as CD, or phi is the dimension of luminous intensity, and the dimension of amount of substance is mole. The dimensions of a physical quantity are the powers to which the units of base quantities are raised to represent a derived unit of that quantity. Example, velocity is displacement by time. It can be written as L by T, and we have to mention it in all the 3 fundamental units. So, m power 0, L power 1, T power minus 1. Hence, the dimensions of velocity are 0 for mass, 1 for length and 1 for time. Okay. Now, let us see what is dimensional formula and what is dimensional equation. Dimensional formula is an expression which shows how and which of the fundamental units are required to represent the unit of a physical quantity. ஒரு physical quantity உடைய யூனிட்டை ரெப்ரசன்ட் பண்ணுறதுக்கு நம்ம யூஸ் பண்ணக்கூடிய ஃபார்முலாக்கு தான் என்ன பேர்? டைமென்ஷனல் ஃபார்முலான்னு பேர். ஃபார் எக்ஸாம்பிள், m power 0 L T power minus 2 is the dimensional formula for acceleration. When the dimensional formula of a physical quantity is expressed in the form of an equation, that equation is known as dimensional equation. Yeah. So, acceleration equal to something equal to போட்டோன்னா அது என்ன ஆகும்? equation ஆகும். Acceleration equal to m power 0 L T power minus 2. Okay. Now, let us see dimensional quantities and dimensionless quantities. On the basis of dimension, we can classify the quantities into 4 categories: dimensional variables, dimensionless variables, dimensional constant and dimensionless constant. So, now let us see what is dimensional variable. So, dimensional variables are physical quantities which possess dimensions and have variable values. Examples, length, velocity and acceleration. லெங்க்த்துங்கிறது அதுக்கு ஒரு டைமென்ஷன் இருக்கும், அது என்ன ஆகிட்டு இருக்கும்? வேரி ஆகும் இல்லையா? லெங்க்த்துங்கிறது எப்போவுமே வேரி ஆகக்கூடிய ஒன்று. லைக் தட் வெலாசிட்டி வில் வேரி, ஆக்சிலரேஷன் வேரி. ஸோ தீஸ் ஆர் டைமென்ஷனல் வேரியபிள்ஸ். நவ் டைமென்ஷன்லெஸ் வேரியபிள்ஸ் அப்படின்னா physical quantities which have no dimensions but have variable values are called dimensionless variables. சில ஃபிசிக்கல் குவான்டிட்டிஸுக்கு என்ன இருக்காது, டைமென்ஷன்ஸ் இருக்காது, யூனிட்ஸ் இருக்காது. யூனிட் இல்லைன்னா டைமென்ஷனும் இருக்காது. ஆனால் அது என்ன ஆகும், வேரி ஆகலாம். ஸ்பெசிஃபிக் கிராவிட்டி, ஸ்ட்ரெயின், ரிஃப்ராக்டிவ் இண்டெக்ஸ் இதெல்லாம் அதுக்கு எக்ஸாம்பிள்ஸ். ஓகே, ரிஃப்ராக்டிவ் இண்டெக்ஸ்னால் யூ மைட் ஹவ் ஸ்டடீடு, சின்ன கிளாஸில் படிச்சிருக்கீங்க. இட் டிபெண்ட்ஸ் ஆன் த மீடியம் இல்லையா. அதே போல் ஸ்ட்ரெயின் டிபெண்ட்ஸ் ஆன் த மீடியம், ஸ்பெசிஃபிக் கிராவிட்டி வேரிஸ். So these are the quantities, they have dimension less, they are not having dimensions and therefore they are called dimensionless variables. Now dimensional constants, physical quantities which possess dimensions and have constant values are called dimensional constants. Example, gravitational constant, Planck's constant, etc. நம்ம ஏற்கனவே பார்த்தோம், கிராவிடேஷனல் கான்ஸ்டண்ட்டுக்கு என்ன உண்டு, டைமென்ஷன் உண்டு, யூனிட் உண்டு, அதுக்கு டைமென்ஷனும் உண்டு. பிளாங்க்ஸ் கான்ஸ்டண்ட்டுக்கும் யூனிட்டும் உண்டு, டைமென்ஷனும் உண்டு. ஸோ இது ஆனால் அது என்ன இருக்கும், கான்ஸ்டண்ட்டாக இருக்கும், வேரி ஆகாது. ஸோ தே ஆர் டைமென்ஷனல் கான்ஸ்டன்ட். நவ் டைமென்ஷன்லெஸ் கான்ஸ்டன்ட்ஸ், quantities which have constant values and also have no dimension are called dimensionless constants. Example, pi, all the numbers, these are all dimensionless constants. Now, principle of homogeneity of dimensions. The principle of homogeneity of dimensions states that the dimensions of all the terms in a physical expression should be the same. For example, we have physical expression v square equal to u square plus 2as. The dimensions are v square, u square and 2as are the same and equal to l square t power minus 2. Now, applications of dimensional analysis. This method is used to convert a physical quantity from one system of unit to another. It is used to check the dimensional correctness of a given physical equation. It is used to establish relation among various physical quantities. These are the applications of dimensional analysis. Now, first application is to convert one system of unit into another. For that, we are making use of the fact that the product of number and unit should be a constant. So, n1 into u1 should be equal to n2 into u2. And here we can have a system which has a dimension in length, a dimension in mass, b dimension in length and c dimension in time. Now we can write this in one system as n1 into m1 power a, l1 power b, t1 power c equal to n2 into m2 power a, l2 power b and t2 power c. So we can convert one system of unit into another by using this method. Now we can have an example given in the textbook. Convert 76 centimeter of mercury into SI units, that is Newton per meter square. This is the question given. 76 centimeter of mercury is in CGS system and Newton per meter square is a SI system. For that, we can take the same P1 into pressure into P1 into, and we should know the dimensional formula for pressure. Dimensional formula for pressure is m power 1 l power minus 1 t power minus 2. This is the dimensional formula for powers with similar terms, m1 by m2 into the whole power a, L1 by L2 the whole power b, and T1 by T2 the whole power c. Okay, and this is 76 centimeter of mercury means 76 into 13.6 into 980 dyne per centimeter square in CGS system. So we have to write that into M1 in CGS system is, mass in CGS system is gram, and in MKS system or SI system it is kilogram. So we can write 1 gram by 1 kilogram is 1000 grams. Power A. A is, we know, the m power is 1, so we can write it as 1, and length in CGS unit is centimeter, so 10 power 1 into 10 power minus 2 meter divided by, in SI system it is meter, so divided by meter into time in both the system are the same, and here the power should be minus 1. Here it is minus 2. Now we can have 76 into 13.6 into, this will be 10 power minus 3, and this will be 10 power minus 2, which is equal to 1.01 into 10 power 5 Newton per meter square. Now the next application is to check the dimensional correctness of a given physical equation. For that, let us take the equation of motion V is equal to U plus AT. While applying dimensional formula on both the sides, we will have Lt power minus 1 for velocity, which is equal to, U is also velocity but initial velocity. For that also dimensional formula is Lt power minus 1 plus the dimensional formula for acceleration is Lt power minus 2. And the dimensional formula for time is t. So t power minus 2 into t power 1 will become t power minus 1. So both the sides have Lt power minus 1 equal to Lt power minus 1 plus Lt power minus 1. So we can see that the dimensions of both the sides are same, hence the equation is dimensionally correct. Okay. Now we can see an example for this. Example 114 in your textbook. Check the correctness of the given equation half mv square equal to mgh using dimensional analysis method. You know what is half mv square? Kinetic energy, is it not? Half mv square is the expression for kinetic energy and mgh is the expression for potential energy. Now we have to check whether this equation, that is kinetic energy equal to potential energy, this equation is dimensionally correct or not. For that, we can have the dimensional formula for kinetic energy as equation of kinetic energy is half mv square, m is the mass, v is the velocity. We need not write the number part. Therefore, the dimensional formula for mass is m, dimensional formula for velocity is Lt power minus 1, and we have to put a square over there, and which is equal to m L square t power minus 2. We have to square L, so L square t power minus 1 the whole square equal to t power minus 2. This is the left hand side of the equation. Now the right hand side is, that is mgh equal to dimensional formula for mass is m, dimensional formula for acceleration due to gravity g is lt power minus 2, and dimensional formula for the height h is L. So when you multiply this or take L's together, you can write m into L square t power minus 2. Now both the left hand side and right hand side are equal, hence the equation is dimensionally correct. The next application is to establish the relation among various physical quantities. If the physical quantity Q depends upon the quantities Q1, Q2, Q3, etc., then Q is proportional to Q1, Q2 and Q3. Then we can write the expression as Q is directly proportional to Q1 power A, Q2 power B and Q3 power C, which is equal to K into Q1 power A, Q2 power B and Q3 power C, where K is a dimensionless constant. When the dimensional formula for Q, Q1, Q2 and Q3 are substituted, then according to the principle of homogeneity, the powers of M, L and T are made equal on both the sides of the equation. So from this we can get the values for A, B, C, and by substituting those values we will get the equation. You will clearly understand this if I give an example. Example is, obtain an expression for the time period T of a simple pendulum. The time period T depends on mass of bob, length L of the pendulum and acceleration due to gravity G at the place where the pendulum is suspended. The value of constant K is given as 2 pi. So we can find the solution for this. We are given 3 quantities: mass, length and acceleration due to gravity, and it is given that the time period depend upon these 3 quantities. So we can write the equation as T is directly proportional to M power A, L power B and G power C, that is equal to K into M power A, L power B, G power C. Here K is the constant which is given. We can write this equation in terms of dimension. So time period, dimensional formula for time is T, and therefore T power 1 equal to, what is the dimensional formula for mass? Yes, capital M. Dimensional formula for length is capital L, and G is LT power minus 2. So we can write M power A, L power B and LT power minus 2 the whole power C. Here we can write in for time period also we can put it in ML form. So M power 0, L power 0, T power 1 equal to M power A. How many L's are there? 2 L's are there, is it not? That is L power B and L power C are there. So we can collect them together, and therefore it is L power B plus C. We have studied A power M into A power N equal to A power M plus N. Like that, L power B into L power C equal to L power B plus C. Now compare the powers of both the sides. m has 0 in the left hand side and a in the right hand side. Okay, so a equal to 0. Then b plus c, L has b plus c in the right hand side and 0 in the left hand side. So we can write b plus c is equal to 0. And t has the power minus 2c in the right hand side and 1 in the left hand side. Therefore, minus 2c equal to 1. So, what is c? c equal to minus 1 by 2. Substitute that minus 1 by 2 in b plus c. So, b minus 1 by 2 equal to 0 you will get. So, we can write it as b equal to 1 by 2. Now, a equal to 0, b equal to 1 by 2 and c equal to minus 1 by 2 are the values you got for the powers. We can substitute these in the equation t equal to k m power 0, l power half, g power minus half. So, m power 0 is 1. So, we can write t equal to k into L by G the whole power half equal to k into square root of L by G. And it is given that the value of k equal to 2 pi. Therefore, we can substitute for k and we get t equal to 2 pi into square root of L by G. Now, limitations of dimensional analysis. We studied dimensional analysis has some 3 applications. Likewise, it has some more limitations. What are the limitations? Let us see. First one is, this method gives no information about the dimensionless constant in the formula like 1, 2, 3, pi, etc. அதாவது ஒரு ஈக்குவேஷனில் இந்த வேல்யூஸ் எல்லாம் இருக்கா இல்லையா அதை நமக்கு செக் பண்ண முடியாது. அடுத்து this method cannot decide whether the given quantity is a vector or scalar quantity. ஒரு ஈக்குவேஷன் கொடுத்துட்டு இது வெக்டார் ஈக்குவேஷனா ஸ்கேலார் ஈக்குவேஷனா அதில் உள்ள குவான்டிட்டிஸ் வெக்டார் குவான்டிட்டிஸா ஸ்கேலார் குவான்டிட்டிஸான்னு நமக்கு கண்டுபிடிக்க முடியாது. And the third one is, this method is not suitable to derive relations involving trigonometric, exponential and logarithmic functions. நமக்கு வந்து எக்ஸ்பொனென்ஷியல் ஃபங்க்ஷன் லாகரிதமிக் ஃபங்க்ஷன் எல்லாம் வந்தால் நம்ம இதை என்ன பண்ண முடியாது, செக் பண்ண முடியாது. And it cannot be applied to an equation involving more than 3 physical quantities. நம்ம ஏற்கனவே பார்த்த எக்ஸாம்பிள்ஸில் எல்லாம் பார்த்தோம், 3 physical quantities வச்சு தான் நம்ம என்ன பண்ணோம், செக் பண்ணோம். ஸோ மோர் தேன் 3 நமக்கு கண்டுபிடிக்க முடியாது. And finally, it can only check on whether a physical relation is dimensionally correct, but not the correctness of the relation. For example, using dimensional analysis, S is equal to ut plus 1 by 3 at square is dimensionally correct, whereas the correct relation is S is equal to ut plus half at square. So, this number part will not be taken into account while writing dimensional formula. With this, we conclude this class and the lesson is also over. Thank you for listening. Bye.